With our post-process volume in place, we also now have the ability to adjust our camera's exposure settings on a per volume basis, meaning we can make sure that each area of our visualization piece will automatically look as good as it possibly can whilst our client is walking around it. Making sure that the post-process volume is selected in the world outliner then, we can do a search for it if we need to. We can come to the lens rollout and find the options that we want under the camera and exposure headings. As we look at our options here, we may ask, what is auto exposure? Well, this particular effect, sometimes referred to as eye adaptation in Unreal, mimics what our eyes do naturally when we, for instance, walk from a bright exterior to a darker interior, in that our eyes adjust so that we can quickly make out details in the new lighting situation. In order to see the changes that we will be making here, let's put a check in all of the options that we have, except for metering mode, and then work our way down the controls. Min and max brightness pretty much speak for themselves. So, if we set our min brightness to a value of 1, for example, our camera's exposure will never drop below that value. In fact, a workflow that I like to use when setting up lighting and GI is to set both the min and max values with the same number, essentially giving myself a fixed exposure that doesn't change when looking from bright to dark. To demonstrate how the system works by default though, let's find a dark space in our level, and then set both controls to a value that lets us see all of the detail found there. So, a value of 0.1 should do nicely, which as you can see, causes our viewport to brighten so that we can clearly see the scene. Let's just write that number down, and then move the view over to the brightest part of the scene, so maybe this small unit under the TV. And this time, try working with a value of 1. Now, this does make the rest of the scene look very dark, but it does ensure that our client will be able to see every detail very clearly when looking at areas of the scene in direct light. Now, we are using some fairly extreme settings just for demonstration purposes here, but as with all things artistic, the choice of exposure setting that we ultimately make will depend on exactly what it is that we need to accomplish with the project that we are creating. And of course, the values used will also depend at least to some extent on light intensity settings in the scene. So, if our sun, for instance, is set to an intensity value of 1000, then we would probably need to use exposure settings of 80 and up. In this instance though, I'm going to set the min brightness to 0.1, max to 0.9, and then again take a look at the darkest and the brightest areas of the scene, which as you can see causes our viewport to automatically adjust its exposure now so as to compensate for the shift in illumination levels, with the speed up option controlling transition speed from dark to bright and the speed down option controlling bright to dark. If we set them both to a value of 8 and then look from bright to dark and back again, we can see this in action. Now this is way too strong and distracting an effect of course, but you can clearly see the effect it has. Let's go back to the defaults of 3 and 1. Finally, the exposure compensation option lets us add a logarithmic adjustment to our overall exposure, a logarithmic scale being used whenever there is a large range of quantities to be encompassed. When it comes to exposure then, a bias value of -1 will make our scene half as bright, whereas -2 will make it a quarter as bright. The same being true of positive numbers. 1 is twice as bright, whereas 2 will make it 4 times brighter. Given that the exposure settings we use will have a direct impact on how the end user sees the GI solutions that we create, being able to adjust this on a per volume basis gives us a fantastic level of control that can again only help ensure that every inch of our GI solution looks as good as it possibly can.